Okay, you now understand that there are two kinds of methods. The static methods, which can only access static data in the class, and the instance methods, which live in the object and can access both static and non-static data. But there's one other major difference. An instance method has a reference named this that you can use to refer to members of the object. There is no this variable in a static method because it's not associated with the object. This class has an instance data item named setValue. The value passed into the constructor is stored in the instance variable. Now, the argument passed into the constructor has the same name as the one defined inside the object, so the line of text that assigns the value needs to refer to the argument value once and the instance variable once. Well, the rule is that any local variable name, including an argument name, is defined inside a method and is private to that method. So, in this method, if you refer to a variable named setValue, that reference will refer to that local variable. The variable at the object level, the one that has been declared outside of the method, has been hidden by one of the same name being defined inside this constructor. In this case, the argument being passed to the constructor is the overriding variable. As far as the this reference is concerned, constructors and methods work just alike. On the right side of the assignment statement, there is no this qualifier, so the local name is used because it overrides the object-wide variable. On the left side, the this keyword is used, so the object variable is being addressed. Now, the same thing is true in these two lines of code, the ones that display the values. One is the local variable, and the other is the instance variable. You can see that the this qualifier is used to specify which variable is being addressed. You won't get a warning on this. Now, the local variable is simply the default, and you can take this to any level. This source file defines two classes. The first one is named SuperOverride2 and only declares a string definition. This is used as a superclass, is extended by the class named Override2. And Override2 contains the string definition, creating its own by the same name. Here in the method named showStrings, another string by the same name is declared. And with these three lines, the three strings are displayed. The first call to line displays the local string because the string name doesn't have any qualifiers, so it just takes the innermost level. The second call prints the string defined inside this object because the this qualifier is used. The third string name has the super qualifier in front of it, so it prints the string defined in the super class. The output looks like this. You can go right on up through the chain of inheritance by using super as far as you need to go. Nothing is completely hidden from you because of overriding. You just have to qualify the name or you'll wind up with a current local name every time. The same goes for overridden methods. If you have a method in your local class definition that overrides one in the superclass, you can directly call the method in the superclass by using the super prefix on the method name. It's rare, but circumstances arise where you'll need to do this. One more thing about methods. A new feature was added in Java 5.0. Method calls with a variable number of arguments. It's really just a new syntax for an old way of doing things. Here, let me show you. Here in the main line, a new object is instantiated, and the showAll method is called twice with a different number of int values each time. And here's how the method declaration looks. The declaration of the argument is in the data type int, an ellipsis, which is just 3 dots, and the name of the data item. This line displays the number of arguments passed into the method, and this loop displays each of the individual values. Notice that the length value and the way each individual member is addressed is by a subscript. Notice that the length value and the way each individual member is addressed is by a subscript. The code is written just as if the values were being passed in as an array. Here you can see that the method displays 5 values the first time it's called and 2 values for the second time. Now there is a reason that the code in the method looks just like an array is being passed into it. That's because an array is being passed in. All the ellipsis does is declare an array. Here is the same thing done in a different way. This program is exactly like the previous one, except that the techniques for passing the arguments uses a different syntax. The call to the method has the argument set up so it explicitly creates an array. And here, instead of using an ellipse to specify a variable list of arguments, an array is declared. And that's the only difference between this program and the previous one. The rest of the code in the program is exactly the same as before. The only difference is the syntax of the source code in calling the method. In both cases, an array was instantiated and passed to the method. Which way you actually do it depends on a lot of factors, like what other arguments you may need to pass to the method. A large part of the decision is a matter of personal preference. This personal preference thing pops up a lot in Java because there is more than one way to do almost everything.